Hello students, let's revise what we have learned in our last class. Okay, so we have learned gravitational waves. What is gravitational waves? So gravitational waves, they are the different types of waves. You all know about the term that is X-rays, gamma rays. Yes, but gravitational waves, they are different, and X-rays, gamma rays, they are also different. Okay, so the scientists constructed extremely sensitive instrument to detect the gravitational waves, and that instrument is called as LIGO, L-I-G-O, LIGO. Okay, then we have learned about the term free fall. What is that? So whenever an object moves under the influence of force of gravity alone, it is said to be falling freely. In the free fall, the initial velocity of an object is taken as zero, and it goes on increasing due to what? Due to acceleration due to gravity. The value of g is same for all the objects at a given place on the earth. And then we have seen that thus any two objects with respect to their masses or any other properties dropped from the same height and falling freely will reach the earth at the same time. I hope you remember that here we have taken the two examples, that is a stone and a feather, and we have seen that whether they will fall on the same time or not. Okay, then we have learned about the various kinds of equation, that is v is equal to u plus at, where u is taken as 0, we have taken u as 0 and a is g, so we'll get v is equal to gt and the two more equations. Okay, so that is about our last class. Now about your test most results, very good participation of students, very good students, keep it up. But next time I want 100% attendance of all the students. Okay, some students, they are not participating. I want 100% attendance, 100% result on your next class. Okay, so now we are moving towards our today's topics, that is gravitational potential energy. What is that? We'll see. Yeah, so the energy which is stored in an object because of its position or state is called as potential energy. You must have seen this, you must have learned this in your last standard, that is ninth standard, that because of the position or state of an object, the energy which is stored in an object is called as potential energy. These energies increases as we go to the greater height from the surface of the earth. Yes, so this energy increases as we go to the greater height. We had assumed that the potential energy of mass m at a height h from the ground level is mgh. What is m? M is mass, g is what? Small g is acceleration due to gravity, and h is height, and on the ground it is 0. When height is small as compared to the radius r of the earth, we can assume that g to be constant, and we can use the formula is mgh. But for the large values of height, the value of g decreases with increase in height. Okay, when the value of height is large, the value of g gets decreases with increase in height. Okay, for an object is infinite distance from the earth, the value of g is 0 and earth gravitational force does not act on that object. If an object is infinite distance, what do you mean by infinite distance? That means a very big height from the surface of the earth, then the value of g is 0 and gravitational force does not act upon that object. So it is more important to assume the value of potential energy to be 0 there. Okay, so the value of potential energy is 0 at an object from infinite distance from the surface of the earth. Thus, for the smaller distances, the potential energy is less than 0 and it is taken as negative. When an object is at a height h from the surface of the earth, its potential energy is minus of gmm upon r plus h. Here the capital G is what? Gravitational constant, m is mass, r is radius and h is what? Height. H is taken as height. So this formula is very important, that is potential energy is equal to minus of gmm upon r plus h. Okay. The next topic is escape velocity. This is very interesting topic. So what do you mean by that? So we have seen that when a ball is thrown upward, its velocity decreases because of the gravitation of the earth. Okay. The velocity becomes zero after reaching a certain height, and after that the ball starts falling down. When we throw a ball in upward direction, it reaches to a certain height and then it come back to the surface of the earth. Yes. Okay, so its maximum height depends upon its initial velocity. Whatever its initial velocity is there with which the object thrown upward, it depends upon its maximum height that object will reach. So according to Newton's third law of equation, v square is equal to u square plus 2as. What is v? V is the final velocity of the ball, that is equal to 0. And a is equal to what? G. Here a is taken as minus g because the ball throw from downward direction to the upward direction. So if we put these values in the equation, what we will get? V is 0, so 0 is equal to u square plus 2 into minus of g, that is a, into s, and the maximum height of the ball, that is s, is equal to minus of u square divided by 2g. If we exchange the term, then we will get s is equal to minus of u square divided by 2g. Thus, higher the initial velocity u, the larger is the height reached by ball. So a ball to be reached at larger height, what is important? Its initial velocity is important. Okay. Higher is the initial velocity, the ball will oppose the gravity of earth more, and larger will be the height to which it can reach. Yes, we seen that. If we keep increasing the initial velocity of the ball, it will reach to the larger and larger heights, right? And above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth and can escape the earth forever, and it will not come back on the earth. This velocity is called as escape velocity. So here initially what happened, when we throw a ball in upward direction, it reach to a certain height and then it come back. But here in the case of escape velocity, what happens is it didn't fall on the surface of the earth. It goes to the infinite height and then it escapes from the earth's surface and it doesn't come back to the surface of the earth again. An object going vertically upward from the surface of the earth having an initial velocity equal to the escape velocity. So its initial velocity has to be equal to the escape velocity. For the object to be free from the gravity of the earth, it has to reach the infinite distance from the earth. Okay, so it has to reach the infinite distance from the earth so that it will become free from the gravity of the earth. Okay, so now we are going to see some equations. That is, for an object of mass m, one object is at the surface of the earth and it is at the infinite distance from the earth. Infinite means a very big height from the surface of the earth. So here, first of all, I have taken, now let's see on the object on the surface of the earth. Kinetic energy is equal to half mv square. You all know that. ESC, which means escape velocity. B, potential energy is equal to minus of gmm divided by r. So total energy E1 is equal to kinetic energy plus potential energy. What we will get? That is equal to half mv square ESC minus of gmm divided by r. Here, if we come at infinite distance from the surface of the earth, that is kinetic energy will become 0. Why 0? Infinite means big height. So at a big height from the earth's surface, there is no speed, no motion. So kinetic energy is 0. Then potential energy is what? Minus of gmm divided by infinity. Okay, here we are going to take infinity because it is at infinite distance from the earth surface, so that will also become 0. So total energy which we will get, E2 is equal to kinetic energy plus potential energy is 0. Okay. From the principle of conservation of energy, what is that? Energy is neither created nor destroyed, but it is transformed from one form to the another. E1 is equal to E2, so that is half mv square minus gmm divided by r is equal to 0. If we exchange the term, then we will get v square is equal to 2gm divided by r. So v is equal to root of 2gm divided by r. If we multiply both the term by r, then we will get root of 2gm r divided by r square. But gm root of, yes, but gm upon r square is what? Small g, that is acceleration due to gravity. So we will get root of 2 gm upon r square. In place of that, we will write the value of the small g, and r is and capital R. So if we put the value of g and capital R, we'll get 11.2 kilometer per second. Okay. Weightlessness in space. You must have seen about this term that in the space there is we observe weightlessness. So what is that? The space travelers as well as object in the spacecraft appear to be floating. What is spacecraft? Spacecraft is a vehicle that is used to travel in the space. So here what happens? The object we seen that the object is floating. Why? In the space station, the value of g is only 11% less than its value on the surface of the earth. Their weightlessness is caused by being a state in a free fall. So there the object is in free fall state, and that's why we observe the weightlessness of that object. Though the spacecraft is not falling on the earth because of its velocity along the orbit, the force acting on it is gravitational force of the earth, and therefore it is in free fall. Okay, the spacecraft being free fall state, it doesn't fall on the surface of the earth because there is a gravitational force, okay, of the earth. The velocity of the free fall is same for the spacecraft, the travelers, and the object in the object in the craft. Velocities of all the objects and spacecraft is same. Thus if the traveler releases an object from her hand, it will remain stationary with respect to her hand and will appear to be weightless. Okay, if an object if a traveler releases an object from her hand, what happens? It didn't fall on the surface of the earth. It will remain as stationary with respect to her hand and appear to be weightless. So we have seen weightlessness in space, then we have seen escape velocity and gravitational potential energy. Okay, thank you.